This video is about segments in circles. So let me give it a title. This will not have to do with the angles. This will have to do with the actual measurements of the segments. Okay, so in the first picture, what do we call this and what do we call this? That is correct. Those are secants. So we have a formula, okay? I call it whoa, whoa. What that means is whole, so the whole secant times the outer portion is equal to the whole times the outer. So let's say that I call this entire piece A, and I call this entire piece B, and then I call this little outer piece C, and I call this little outer piece D. Okay, then the formula would come down to being A times C equals B times D. Now keep in mind, they can trick you. They can give you this piece, okay? So if they give you this piece and they give you the red piece, how would you get this yellow piece, D? That's correct. You would subtract. They could also give you D and then the blue piece. How would you get B? That's correct, you'd add. Okay, so now let's take a look at the second picture here. So in this second picture, what do we call this? That's correct. That's a tangent. And what do we call this segment that goes all the way over to here? From here? Yes, that's a secant. Okay, so in this case, the formula is going to be root. So what this means is that the whole, so here's the whole for the secant, times the outer part for the secant, whole times outer, equals tangent times tangent, or tangent squared. Okay, so again, they can do all sorts of things here. They could give you this piece here. We're going to see some examples in a minute. And then you'd have to know to get the yellow piece. If you had the blue piece, you would subtract the red, and things of that sort. Okay, let's go to the next page. So these are the formulas that you're going to have to know in order to actually answer any questions. So here, in the top picture, okay, what do we call this segment? That is correct. And then, what do we call this segment? Okay, that is correct. So we have two chords. So with this formula, what you're going to do is you're going to have four pieces. You're going to have this piece here, which I'll call A. Then you're going to have this piece here, which I'll call B. Then you'll have C, and then you'll have D. So the formula would be A times B equals C times D. Eventually, when I do proofs, you'll see where some of these ideas come from, how they actually come together. Where do these formulas come together? So when you have a chord, it's just piece of chord 1 times other piece of chord 1. Okay, equals piece of chord 2 times the other piece of chord 2. All right, so in the bottom picture, we have 2 tangents, right? So what you need to memorize about this is that when you have 2 tangents drawn to a circle from the same external point, here's the external point, those tangents will be congruent. So 2 tangents drawn to a circle from the same exterior point are congruent. So now we're going to take a look at some problems that use these rules. So in this top question, I gave you the red piece, the yellow piece, the green piece, and the blue piece. So we're going to use the formula WOOT, right? I mean, whoa. Whole times outer equals whole times outer. Okay, so for this secant, how would we represent the whole? Right? You have to add. Then the outer would be x. For the other piece, the whole would be 9. The outer would be 4. So you are going to have to factor in some of these problems. Distribute, bring the 36 over. X squared plus 9x minus 36 equals 0. And now you have to find 2 numbers which multiply to negative 36 and at the same time add to 9. So when you're looking for those numbers, you have to think about the factors of negative 36. So you could have negative 1, 36, or vice versa. You could have 1, negative 36. You'd have negative 2, 18, 2, negative 18. Then you could have negative 3, 12. Or you could have 3, negative 12. Your other choices, you could have negative 6, 6. So which pair of factors adds to 9? There you have it. So now you're going to have x minus 3 times x plus 12 equals 0. Set each of these equal to 0 and get your answers. Now, your answer has to make sense in the context of the problem. Does it make sense for x to be negative 12? Certainly not. So then your answer would be 3. All right? So obviously I'm finding x in this problem. Looking at this problem on the bottom of the page, what formula are you going to use? Whole times outer equals tangent squared, right? So what's this whole? Good. What's the outer part? Okay. And then you have x squared. So you get x squared equals 40. So be prepared to have to simplify square roots. However you want to do it. So you could do it this method with the factor tree, 10, 4, 2, 5, 2, 2. And then you look for pairs. You have a pair of 2's, so therefore x is 2 square root of 10. All right, you could also say x equals the square root of 40, which is the square root of 4 times the square root of 10, which is 2 rad 10. Okay, that's your choice. In this problem on the top of the page, I just wanted to mention that when you have chords that are congruent in a circle, those chords must be equidistant from the center. Okay? So, congruent chords are equidistant from the center. Okay, so you never know when that's going to come up. All right, the last question. You have two chords that are intersecting in a circle. So we use the piece of one chord times the second piece of the same chord equals the first piece of the second chord times the second piece of the second chord. So in other words, we have 5 times x equals 6 times 10. 5x is 60, divide by 5, and you get x is 12. Now keep in mind, they could do something here. Let me just show you on the next slide. This is a typical question they could give you, where you have a circle, and then you have a chord here. You have another chord, okay, which is perpendicular. And we know that when you have a chord perpendicular to another chord, it bisects it. So let's say this is XX. Let's say this is 2, and then this piece is 18. So in this case, you'd have x times x, or x squared, equals 2 times 18. X squared is 36. And therefore, each of those pictures is 6. Okay, keep that in mind. That can definitely happen. Remember, geometry comes in layers, so we can add an extra level of difficulty by asking you to find this here. So if this is 6, right, and that's 18, now you could use the Pythagorean theorem. 6 squared plus 18 squared equals c squared. And then I'll work that out. So you have 36 plus, okay, I think 18 squared is 324. Let me double check. Yep, that is correct. That's what happens as you get old, people. You guys get this stuff memorized. All right, repetition works. So anyway, I get 360 is c squared. Therefore, c is the square root of 360. 36 times 10, you can break it down like this, 6 square root of 10. Or again, you could take the 360 and break it down as follows. You could just pick 36, 10. You might not realize 36 is a perfect square. Maybe you'd realize then when you wrote 6 and 6, maybe not. A lot of times we're not really focusing as much as we could. So these will go together. That's one pair. Then these 3's will go together. That's another pair. And then what stays trapped inside is 2 times 5. 6 square root of 10. All right, I hope this video helps you to complete your Castle learning assignment for this week. Thank you very much.